So I'm going to explain about tree. So there will be the basic definition about tree, and what about the how we can explore the tree, and what kind of other tree that we can learn from this section. Tree ADT. So in computer science, a tree is an abstract model of hierarchical structure. A tree consists of nodes with a parent-child relation. So this is parent, this is child. So if it is parent, then it is the child. If it is the parent, then it is the child. Oh, sorry, if it is the parent, then it is the child. There are many applications of the tree. We can see on the organization charts. We can see the file system. So in the file in your computer, we use also the tree. And then some programming environments, if you already have the function or the class, so it's also use tree. So some tree terminology that we need to understand. First is root. So the tree have root, and the root is node without parent. And the tree has internal node. The internal node means the node with at least one child. So for example, C. C is a node and there is a child. But what about D? D is a node, but there is no child. So it is not internal node. The meaning by internal node is a node with at least one child. For example, A, B, C, and F. If this is a node without children, we can say it as external node or leaf. AKA, do you know? As known as. AKA, it means as known as. So the external node or as known as leaf, it is node without children. So we have E, I, J, K, G, H, and B. We call ancestors of a node because we can see the upper level. If it is parent, then it is one level. But if it is grandparent, it is two level. If it is grandparent, it is three level. 1, 2, 3. We have the depth of a node. The depth of a node means the number of ancestors. So if we have 1, 2, 3, 4, then the depth is 3. Let's say if I want to know that what is the depth from A to F, then it means the depth is 1, 2. The head of the tree is the maximum depth of any node. If I want to know the head of this tree, so this tree is the maximum depth is 3. Descendant of a node, it means we want to check what is the node afterward. So the descendant is the child. It is the level, the first level after the node. Grandchild is the second level after the node. The grandchild is the third level. 1, 2, 3. The third level of the node. we have subtree. Subtree means the tree consisting of nodes and its descendant. So we call this is a subtree because this is a node and we have two descendants. We call this is also another subtree because this is a node and they have descendant. So in the tree ADD, commonly we have generic method and accessor methods. So we use position to the abstract nodes. You know the position, last time we learned about the position list. And some generic methods, we have length. It is to know how many elements in the tree, how many nodes in the tree. Is empty, whether the tree is empty or not. We know the positions to iterate this position, or we can do the iter. We can just do the iteration for each element. When we want to do the accessor, or when we want to access some of the node, we can access the position of the root. We can access the parent of P. P is a particular position. We can access the children of P. So it is a position. And then we can access the number of children of P. The number of children of a position. We can query. The query method means I want to know whether it is a leaf or not. What is leaf? Leaf is the external node. And I want to know whether it is a root or not. Root means it is the node without parent. We have update method. The update method means I want to replace a particular position with an object O. So we learned the position last time. There can be additional update methods. It may be defined by the data structures implementing the tree ADD. So you can have more about the tree ADD. So this is the example of the class tree. Here is the class tree, and then we have the class position. Last time we already have the position. We know the element equal to, not equal to, and we can define whether it is the root, the parent, the number of children. So this is the parent of P, the number of children of P, children of P, and we want to know the length of the tree, and whether it is a root, whether it is a leaf, whether it is empty. So when we do the searching on a tree, there are some methods we need to understand. The first, we call it as pre-order traversal. A traversal, it means it is a way to visit the nodes of a tree in systematic manner. You have the tree and I want to visit every node in a sequence. So we need to know about the traversal. Pre-order traversal means a node is visited before its descendant. So I have the position 1. I will visit this node, and then this is the ancestor. because the requirement is a node is visited before its descendant. Then after I visit this one, I can visit the left, this one, and then I will visit this one. Okay, finish, because I already visit all the nodes before its descendant, and then I can visit this one. Okay, no other left from the descendant, so I can go back to the root, and then I move to next node, and then I visit this descendant. After I finish this descendant, I go to this descendant, and then because there is no other descendant, and then I will return back, and then I will visit this descendant. So some application, it can be a kind of print. If you print the document in the computer, so it will follow this kind of mechanism. The algorithm can be seen like this one. So if you understand the recursion, okay, why we need to understand the recursion? Because many of the algorithms, they will apply recursion. We have the algorithm pre-order V. V is a vertex. V is a node that we visit. Okay. So visit V. So let's say I'm visiting V. So for its child W of V, so we have how many child? 1, 2, 3. For each child W, sorry. So we will do the pre-order of W. Then I will go to this one first, because this is the first. I will do the pre-order W. It will go back to this method. And then I will check. Now I visit this node. And then for each child W of V, I have 2 child. Then I will have this first W. And then I will do again pre-order. After I do the pre-order, I visit this V and then check, is there any child? No child. Then because there is no child, we will go to the next for loop. So after I finish with this one, I will go to the other child. And after I finish with all this for loop, then I will go up to the previous node. Because everything was finished here, then I will go back to the previous node. And I will move to the next for loop, which is the next one. So this is the algorithm. There is another traversal, we call it post-order traversal. In the post-order traversal, a node is visited after its descendant. So the application computes space used by files in a directory and its subdirectory. So in your computer, if we want to calculate how many documents do we have, so it will start from the document 1, and then we will check another document in particular folders, and then we can sum the number of documents, and then we can some kind of calculate how many documents do we have and what is the size of this folder. So this kind of way, we call it the post-order traversal, because we will visit from the descendant, from the child, or yeah, this is the descendants, and then we go to the ancestor. Descendant first, and then ancestor. And then we go to another descendant, 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 and we go to the ancestor. And then we have another descendant, and we go to the ancestor. So the way to do this one, we will have the algorithm with post order V. For each child W of V, post order W. It means I will start from the first. When it is the V, for each child W of V, so I have 1, 2, 3. So I have 3 childs. And then I will do the post order W. So the first I will do the post order. What is the post order? Here I will check the child. For each child of this node, I will do the post order W. So I will do again on this node. And for each child, because this child has no descendant, then we will just do the visit. So it will be checked, it is visited. After we check this visited, then it will go back to the previous one, and we go to next column. So this is the post order transfer. We have the binary trees. A binary tree means a tree with the following properties. Its internal node has at most 2 children. So I have the internal node, which is A, and it has 2 children. I have internal node, I have 2 children. I have internal node, at most I have 2 children. So it means exactly 2 for proper binary trees. My question is it possible if I have only 1? Is it possible if I have only 1 node here? 1 node here? The requirement means that we have at most 2 children. At most 2 children means the maximum is 2. So 1 is possible. But if everything is exactly 2, so this one, it means it is exactly 2. This one exactly 2. So this is also exactly 2. So we call this is proper binary trees. Because every node, every internal node have exactly 2. The children of node are an ordered pair. Ordered pair means I have P, and then I have P and E. So these children, it is an order. So after the left, we go to the right. We call the children of internal node as left child and right child. So this is left child, and this is right child. Alternative recursive definition, a binarity is either a tree consisting of a single node. So when you define the recursion, okay? So in last week you did the learning check. You need to define the base. In the base of a tree, or in the base of binary tree, we can say that the tree, when it is consisting of a single node, then yeah, we can finish. Or a tree whose root has an ordered pair of children, each of which is a binary tree. So if this is a root and it has two children, okay, this is a binary tree. And then let's maybe because this is the root and it has two children, then yeah, this is the binary tree. We can use it as the arithmetic expression. We can use the decision process or something like searching. We can use these binary trees. In the arithmetic expression, usually we can say that the internal node is the operator, and then the external nodes are the operands. What does it mean? This is internal node. This is internal node. So the internal node is the operators: plus, multiply, minus, multiply. And then the operands means the number, or this is the external nodes. So 2, A, 1, 3, B. If we look at this kind of tree, then the arithmetic expression tree for this expression is 2 multiplied by A minus 1 plus 3 multiplied B. So we follow the post order travel like this one. We can have the decision tree. So it is a binary tree associated with the decision process. So if you learn about the machine learning, yeah, you will know that the decision tree is a kind of decision where the internal nodes is kind of question or condition. If we have question with yes or no, then let's say you want to have a fast meal. Yes. So do you want a coffee? Yes. Okay, maybe you can go to Starbucks. Or if I don't want coffee, then you can go to, yeah, this is another name for the, maybe just juice shop. And then if you do not want to have a fast meal, so you want to have a fine dine, maybe on expense account. So if it is expensive or not. If no problem with the price, then you can go to this restaurant. If you need to consider the price, then you can go to this restaurant. So the external nodes is the decision. So this is the decision or the place. So the binary trees, because this is proper binary trees. What is proper binary trees? The binary tree with exactly 2 for the internal node. So for the proper binary trees, we can have these following properties. So let's say n is the number of nodes, and then e is the number of external nodes. I is the number of internal nodes, and h is the hit. So we can see the binary tree like this one, and we can see also the binary tree like this one. Okay, now let's see. In this case, how many nodes do we have? 1, 2, 3, 4, 5, 6, 7. Okay. How many E? E is the external node. Then we have 1, 2, 3, 4. I is the number of internal nodes. So how many internal nodes? We have 3. 1, 2, 3. So E equals to 4, I equals to 3. What is the head? It is 2. Okay. Now N equals to 7. So the following properties is this one. E equals to I plus 1. What is E? E is the external node. E equals to I plus 1. I is 3. Okay, so it is correct. E equals to 3 plus 1. N equals to 2 multiplied by E minus 1. So we have E. What is E? External node equals to 4. So 2 multiplied by 4 minus 1. 8 minus 1, it is 7. Okay. So the N is 7. X is less than or equal to I. X is less than or equal to I. Okay. So you can see that this proper boundary trees can be seen as this following. In this case, N equals to 7. And what about E? E, the external nodes, we have 1, 2, 3, 4. What about the internal node? We have 1, 2, 3. What about the head? 1, 2, 3. Okay. In this case, the head is 2. But in this case, the head is 3. So that's why X will be less than or equal to X will be less than or equal to N minus 1 divided by 2. What is N minus 1 divided by 2? We have N equals to 7. 7 minus 1 divided by 2. Then it is 3. So the 3 is the same with the number of I. Okay. And E is less than equal to 2 power of h. E is for less than 2 power of h. 2 power of h. It is, if the h is 2, then E is less than or equal to 4. If h is 3, then E is less than or equal to it. And then h is higher than or equal to log base 2 E. We have h, let's say this one, 2 is higher than or equal to log base 2 E, log base 2 4. Then it means we have, it is 2. So h can be 2, h can be 3. H is higher than log base 2 n plus 1 minus 1. N plus 1. So n which is 7 plus 1, it is 8. So actually this one is 1. Log base 2, 8, it is 3. Okay. 3 minus 1, 2. So the 8s can be either 2, 3 or higher. Okay. At this, the 8 is 2. Okay. So the tree ADT and the binary tree ADT is different, because the binary tree is at most 2 children, and the binary tree ADT extends the tree ADT. It inherits all the methods of the tree ADT. So it means we can also extract the position, we can extract the length, we can extract the iteration. But there will be some additional methods to check where is the left of P, what is the left, what is the right of P, and what is the sibling. So what do you know what is sibling? If we have node, we know this is the left, we know this is the right, and both of them are sibling. So update methods may be defined by the data structure implementing by the binary tree ADT. Okay, I will keep this one for the Wednesday class. I will explain more because I need more time to explain this traversal. Okay, any questions? So I will finish the class today.